last month, where Dan and I were talking about, would technologies such as the semantic web take off? And I guess, fundamentally, there's still the problem that we're adding an ever-expanding number of pages to the web. Huge knowledge base, like you said, to the point that, it almost becomes unimaginable to try to figure out what kind of queries you can run that are going to return meaningful information unless we really elevate the technology a level or two in terms of being able to describe the data that's out there and provide, metadata for this very large-scale database. So that, again, when we think of computing in the large, we go back to this problem of, if there are billions of people with devices that are connected that want to run queries, even though it may be a query behind the scenes because they're actually going to order something or they want to check the weather or something on their phone. That brings me back again to the question of database technology. Do we have the technology to support billions of people concurrently doing those kinds of things? And so I guess one of the questions is, where do we see the technology going in the next few years in terms of things like tuple spaces, T-spaces technology, in-memory databases, or are there some other solutions that we need to look at to provide database connectivity on that scale? Again, anybody on the panel? Go ahead.
Well, I think in-memory database is a no-brainer. I think probably most of the panel would agree that a lot of databases are getting to a state where they can be in-memory. And so there's still not enough computation power. You may have to put on memory on lots of machines in order to get the throughput that you want, but that seems like an obvious thing to do. Tuple spaces or Genie Java spaces type tuple spaces are an interesting new technology. There's both a database and a communication mechanism and an operating system in the sense that you can put things in this tuple space. It's a space that is an association or a message that's going to be retrieved out of the tuple space from someone else. That I think is interesting, but I wouldn't predict that it's going to take over the world. I think it's still in an advanced development research kind of phase where a number of universities and bleeding edge companies are playing with that technology to see what they can do with that.
Jim?
I think that there's a variant of tuple spaces which is workflow and queue-oriented processing. And increasingly, computations are being structured as a workflow or email or something where I send you something and then you do something. And increasingly, those flows are being described in XML. And in fact, the reason for that is that I want my flow and your flow to dovetail. So this is an area which we've been talking about for many years. And surprisingly, we're seeing a lot of progress these days. There are products that exist. People are using them. This is an area of ferment, I'd say.
So I have one final question before we turn it over to the audience. It seems like, particularly starting sometime in the 90s, it became fashionable to write something to the effect that databases are dead, database technology is dead. It started, I guess, probably in the early to mid 90s, and then of course when the web and the internet became important, there was another variant. Databases are dead, can't handle the complexity of the web, the type of data of the web, et cetera, et cetera. Now, the way I've always looked at it is sort of like, if you're building a car, you need an engine and a transmission. And I guess I don't see exactly how those things are going to go away. Anybody have any opinions? Is there going to be something to displace database technology? Jim?
I think anyone who thinks databases are dead would probably think computers are no longer useful. We will increasingly need databases, just the way we need memory and processing power and disks and everything else. It's probably true that storing traditional data is a well-understood problem. It's largely been solved. Storing text data is a largely solved problem. But there's some incredibly interesting problems that are just now beginning to be addressed. I can imagine people asking queries like, find me all of the security videotapes in which this person appears, but not as a photograph on a placard, a real live person. That's a pretty interesting application, and nobody has the vaguest idea how to resolve that yet, but there's a lot of people trying to figure it out. Or find me all of the music tracks in which the F word appears within 3 bars of the opening of Beethoven's Fifth. How would you go about solving that? But the data is going to be out there. You have to be able to join data of all sorts of different types, spread across possibly millions of nodes on a network. There's no metadata for anything like that today. In fact, the vast majority of the world's data doesn't have metadata. We have to figure out how to put all of these pieces together. And that's the job of database today, and it's growing.
Don, you had a comment?
Yeah, I was going to say many of the same things that Jim did. I think that we have a set of challenges that are coming up in the database field that are going to keep PhD students busy for decades to come. I think if you look at data in XML format, you're going to find lots of kinds of queries that are structurally different from the kinds of queries that we've been used to. And that's some of the challenges that we've been thinking about in the XQuery working group. XML data tends to be heterogeneous. So if you ask a question like, find all the red things, well, you're going to get back a stop sign and a cherry and a red bicycle. And this is not something that looks like rows and columns. We need whole new programming interfaces to deal with this kind of heterogeneous data. We need to deal with the concept that XML data is very often ordered. Order is an intrinsic property of the data. That makes it fundamentally different from relational data, which is unordered. And that makes many of the optimization techniques that we're used to in the relational world obsolete, because we have to think of a whole new way to optimize queries in an ordered world. We have to think about ways to ask questions and process those questions that deal not only with the data, but with the metadata as well. You might ask a question like, what kinds of things are read? That's a kind of a question that's very difficult to ask in a relational world. But in an XML world, that's an important kind of a question. We need to have whole new ways of dealing with sparse data. The relational databases use nulls for that purpose because relational data is very well structured, and every row of a table has basically the same structure as every other row. But every element in an XML document may have a unique structure of its own. And as a result of that, we'll process sparse data in a whole different way, and the logic around nulls and three-valued logic is probably going to come out different in an XML query language. XML databases need more robust mechanisms for constructing things because since an XML document is hierarchic in structure and carries its own metadata with it, you have to have mechanisms for constructing hierarchies and for constructing the metadata that goes along with them that are much more sophisticated than the construction techniques that we typically have in relational databases. So I don't think this is it doesn't sound like a dead field to me. It sounds like a very exciting field to be in, one where there's plenty of work left to do.
Yeah, Rick?
Let me just add, I think when people say databases are dead, they must be thinking that relational databases have matured. They're just moving very slowly. They're not dead. They're moving imperceptibly, and it's hard to find a thesis topic in relational database or some kind of SQL query optimization anymore.
You know, unfortunately, we don't have a tremendous amount of time for this session. When I got an email from Michael Kay in the UK when he saw the announcement of the panel and the panelists, and he said, you know, it sounds like you're trying to do television where everything is a 30-second soundbite. He said, with a panel like that, you know, each of those panelists should have an hour. Unfortunately, we don't, but we do have about 15 minutes more for questions. So if you would like to ask a question, go ahead and raise your hand. We have somebody, actually we have a couple of people who have microphones. There's a person in the back. We have someone up here with his hand raised. It's kind of hard for me to see. So hopefully the people in the back can see if somebody raises their hand.
I've heard over and over that the people in the panel are saying, how are we going to query all this data that's in the web unstructured? And is that the real goal, to query that unstructured and undescribed data? Or is the goal to find a way to describe the data so it can be queried.
Did everybody hear that?
Yeah.
Okay. Yeah, I think the first step is describing the data. Build a common schema so that you can ask queries of it. Maybe I'll defer the question to the other panelists.
Yeah. Dana? Everybody has an answer. That's good.
Fortunately, as Don explained earlier, XML has the advantage of its self-describing. We can query a piece of information in XML independently whether it has a schema or not. It has a schema, even better. We can do better optimization, and we can probably ask better queries. But we can ask queries even in the absence of information about the structure of the data, which is extremely important. My guess is more and more verticals will decide to adopt a certain schemas to have a uniform way of exchanging information among them.
Yeah,
but not all the data will be described as schemas.
Mr. Melton?
First thing is there are no silver bullets, and there never will be. There's only tools. I said earlier that the great majority of the world's data doesn't have metadata associated with it. I think it never will have metadata. However, data that has financial value can sometimes have metadata associated with it, whether it's schemas and DTDs and the other types of metadata for structured and semi-structured data will depend on what you're trying to describe. But we're struggling to find ways to query data that is well-defined, that does have good metadata. We're also struggling to find ways of querying data that is so unstructured that two separate data have nothing in common, and yet we need to query them together. It would be a Herculean, if not Sisyphean task to try to describe all of the world's data over which we have no control.
Jim?
Something that hasn't come up yet, and I think it's responsive to your question, is that there is a bunch of data sources right now which are a mess. There's something called LDAP. LDAP objects have 7 mandatory attributes and about 1,000 optional attributes. When you publish LDAP as a table, it's a mess. Publishing it as XML is actually pretty appropriate. So there are things like LDAP, schedules, email, invoices. So SAP can sit and say, okay, most people who do commerce now and who deal with a company that has an SAP system are compelled to buy an SAP system on their side so their SAP system can talk to your SAP system. And if you happen to be a supplier to GM, that's the story. And if you supply to Ford, you'd better buy a bond system so that your bond system can talk to Ford's bond system. So the promise of XML is that there could be a standard invoice that is crosses both SAP and bond. So there's a bunch of forces which are going to encourage people to publish data in an XML format, which is fairly structured. The Microsoft guys I've been talking to were trying to do My Services, and they were trying to come up with a description of what a person is and how people could have attributes. And they, in fact, were storing everything inside of a perfectly normalized SQL database. But everybody on the outside was seeing the information as documents, XML documents, and we're writing queries against those documents. So I think one model of the world is, there's this completely unstructured internet. But another model of the world is there'll be people who want to provide information, and in fact the information is structured, but it's not as rigid. It's more LDAP-like than table-like.
I see another question over here.